class, and today we'll be learning the laws of indices. Indices is a fundamental basics of algebra. The knowledge of indices is going to help you in solving basic algebra questions. Mastering the laws of indices is also going to be a fundamental in understanding topics like differentiation, integration, and also part of trigonometry too. So the laws of indices is the first step you need to understand and master to then be able to know how to solve initial equations. So today we'll be looking at the laws of indices. Basically, there are 7 main laws of indices. But in today's class, I'll be giving you 9 laws of indices. I'll be giving you an extra 2 laws of indices that are not common. But these extra 2 laws are very, very fundamental. So stick around to the end of this lesson to know the other 2 laws of indices. That are not very common, but they are very, very important. It's important to know these other 2 laws. So stick around to the end of this class, and then you're going to learn the extra 2 laws I'm going to be giving you as a bonus. So the first law of indices we'll be learning about is the first law of indices we'll learn about is the multiplication law. It's a multiplication law. And this law just simply says that you have a to the power of m multiplied by a to the power of n. All this simply means is that again a to the power of n. All this simply means is a to the power of n plus n. That is, if you have a base a, the power of m could be any number, m could be any variable, multiplied by another base. Take note, the bases must be the same. So a raised to the power of m multiplied by b raised to the power of n is not equal to a raised to the power of m plus n. Take note, the basis must be the same for this first law to hold and take place. Example, you have a question that says, let's say simplify 3 raised to the power of 2 multiplied by 3 raised to the power of 4. This simply means 3 to the power of 2 plus 4 or to 3 to the power of 6. Now basically there are 2 things here. 3 to the power of 6, we can actually simplify this by saying 3 to the power of 6. 3 to the power of 6 is the same thing as saying 3 into 6 places. That's 3 multiplied itself 6 times. That will give you 729. If we do this, this is the same thing as saying 3 times 3 multiplied by 3 times 3 times 3 times 3. Why 3 times 3 is 9 multiplied by 3 times 3 into 4 places, that's going to give you 81. If you multiply 9 by 81, you're still going to have 729. Do you see how easy it is to just know the law? So why going through this long process, when you could just easily do this and arrive at the same answer? So you see why knowing the basic laws of indices is very, very vital and important. You can see so many more examples. Because of this lesson, I'll be solving more examples and we'll be applying each of these laws. So we're going to master the laws as we keep solving exercise questions. So let's move quickly to the second law of indices. Without wasting much time, the second law of indices is the division law. The division law is just saying that when base, call it a power of m, dividing another base, same base, a to the power of n. What this simply means is that means a to the power of m minus n. This simply means if we have 4 to the power of 2 divided by 4 to the power of 1, this simply means 4 to the power of 2 minus 1, which is 4 to the power of 1, same thing as 4. That was very easy and straightforward. So whenever you have two bases dividing each other, it's just the subtraction of the powers and then you get your answer. Third law we are looking at is called the zero index law. It's called the what? Zero index law. Feel free to write all these things down and later you can go through your notes to learn and master them again. So the zero index law is just saying that if you have a base a to the power of 0 is equal to 1, this simply means whatever number you raise to the power of 0, you must have 1. 20 to the power of 0 is equal to 1. 89 to the power of 0 is equal to 1. Whatever number you raise to the power of 0, that number automatically turns to 1. I don't care what that number is. I don't care what that number is. As long as that number is an integer, you must have 1 once you raise it to the power of 0. This brings me to the fourth law of indices. Remember, I told you I'm going to give you 9 laws. 7 basic common ones, but I'm going to give you an extra 2, so stick around to the end of this video to learn the other 2 laws I will be giving and sharing to you. The fourth law of indices I'll be talking about today is called the negative index law, or the negative index law. And this law simply says that if you have a base, say a to the power of negative n, this simply means 1 over a to the power of n. Now take note, this negative index law, it's very, very important because when we're solving differential equations, we are going to use this very law solving most differential equations. So make sure that you don't forget the negative index law. It's very, very important. An example is if we have question, let's say 5 to the power of negative 1, this simply means 1 divided by 5. If we have a question that says, let's say same 5 to the power of negative 2, this simply means 1 divided by 5 to the power of 2. Whatever number you have to the power of a negative number, now this is how I let my students master this, not to forget this trick. And I'm going to teach you this. We have a to the power of negative n. It simply means I always look at this negative sign as 1 divided over. That's what I always take this negative sign as. This is a tricky way I teach my students how to recall this. So whenever I see this negative here, I see it as 1 over a certain number. So that means I have represented negative sign by 1 over. And then what's left? What's left is what I'm seeing here, which is a to the power of n. Easy peasy. So that's just the way I teach students to memorize it, so that, because sometimes it confuses a lot of my students. So just in case you fall into that category, an easy trick to always remember that. The fifth law of indices we're learning today is called the fraction index law. It's called the fraction. What does this law state? This law is just saying that if you have a, this time around the power is a fraction. If you recall, what we've been learning, the power has been just an integer. It's not been a fraction. So what if the power is a fraction? What if you raise the base to a fraction? What does that simply mean? It simply means that this is going to be the nth root a to the power of m. So if you have, let's say, a base 3 to the power of 2 over 3, what this simply means is the cube root of 3 to the power of 2. So this is our m, this is our n. And what's our n? 3. And what's our m? The power, 2. Whenever you have a base, power of a fraction, this is the law you need to apply. It's called the fraction index law. So whenever you have a base to a fraction, to the power of a fraction, the denominator becomes nth root, and then the numerator m becomes the power you raise that to nth root to. Example again, if I have a fraction, or let's say if I have the base, so 16 to the power of 1 over 2, this simply means square root of 16 . So this is what it means. But basically in mathematics does not permit me to put 2 here and take this off. And also 2, I can take 1 off, because irrespective of the fact that there is nothing yet, it's automatically I know that there's a 1 here. Okay, so mathematics permits me to write this. Mathematics permits me to write this, yes, this, and not as this. Though if I write it like this, it's not like it's incorrect. Doesn't mean it's incorrect, but not permitted. It's not the culture in mathematics to write it that way. Okay, so that's what the fraction index law states. Move to the sixth law, which is called the power of a product rule. Power of a product rule. Power of a product rule. This tells me that if I have base A multiplied by a base B, remember we'll say product. So you can see A and B are products of each other. They are multiplying each other. And then we take it to a power. And what this simply means is A to the power of n, B to the power of n. It's quite different from when you're having A to the power of n. Okay, This just simply means a to the power of 1 times n, which is equal to a to the power of n. But this time around, this base is a product. So the power is multiplying the a and also going to be raised to the power of b. That's basically what the product power of a product will state. So for example, if I have, let's say, this is an example. Take note, the bases here are different. So if I have 3 and I have 3x, let me put it that way, the power of 2. This simply means 3 to the power of 2 multiplied by x to the power of 2 is equal to 3 to the power of 2 is 6 multiplied by x to the power of 2, which is equal to 6x squared, which is absolutely correct, but not 3x squared is not equal to 3x squared. These are two different things, okay? All right, 3x squared is not equal to 3x. This is not equal to this. If I write it this way, that's 3x squared. This is now equal to this. Can you see the difference? Difference is that here I'm saying that 3x with a bracket all to the power of 2 is equal to 3 to the power of 2 multiplied by x to the power of 2 using this law, which is called the power of a product rule. Using this law, that's what I have, and this is going to give me 3 to the power of 2 is 3 times, oh sorry, this is 9. Oh, I'm sorry for that. This is going to be 9. Going to be 9. So 3 to the power of 2 simply means 3 times 3, and then multiplied by x to the power of 2, x squared. So this is equal to 3 times 3, that's 9, multiplied by x squared, and that's going to be 9x squared. So you can see the difference between this and this. See that we are not having the same answer. So that's because of the power of a product rule. Okay, let's move to the 7th law of indices. The 7th law. We're talking about the 7th law right now of indices. And 7th law is called the power of a product rule. Okay, that's what we just learned. The power of a quotient rule. Power of a and the power of a quotient rule, just like the power of a product rule we just learned, this time around it's the bases are the quotients of each other. So that means we have a divided by b all to the power of n simply means a to the power of n divided by b to the power of n. So if you have, let's say for example, same way, let's use that same question. Let's say we have 3 divided by x to the power of 2. It simply means 3 to the power of 2 divided by x to the power of 2, which is equal to 9 divided by x to the power of 2. Now, this power of a quotient rule and the power of a product rule are the two extra laws of indices that I was to mention to you. That the two extra laws of indices that is not really common in the laws of indices, but I needed to point this out to you. And these two laws you see here are very, very important while learning or while solving differential equations. So you need to understand these laws, master them for you to be able to solve differential equations. We are going to solve some examples to help ourselves in understanding this law of indices. We have one question here I'm going to solve. And this question I'm going to solve right now is going to help us to understand all these laws, because we're going to apply the laws of indices. Why 2 to the power of x plus 1 plus 3 to the power of 2 is equal to 3x to the power of x plus 3 plus 3 to the power of x. First thing we need to do, we need to apply the first law of indices, which I told you about, which is the we can apply the addition law, the multiplication law of indices, that states that I can transform this. First of all, let me rewrite this equation. Let me call my equation 1. 3 to the power of 2x plus 1 is the same thing as saying, that's using the multiplication law, this is the same thing as saying 3 to the power of 1 multiplied by 3 to the power of 2x. Recall the multiplication law that states that a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. So this is a to the power of m plus n, and this is a to the power of m multiplied by a to the power of n. You could see that was how I was able to transform this into this guy. So having that in mind, proceed by saying you can also transform the second one, which is 3 to the power of x plus 3, the same thing as saying 3 to the power of x multiplied by 3 to the power of 3, which is the same thing as saying 3 to the power of x plus 9 is equal to 3 to the power of x multiplied by 27 plus 1 multiplied by 3 to the power of x. Now what I just did, I just transformed this to this. There's 1 multiplied by 3 to the power of x. I have not changed anything. It's the same thing as 3 to the power of x. So me transforming this to this, I have not changed anything. Mind you, this is multiplication, not a decimal. It's multiplication. So I have not changed anything by doing so. But the reason why I did that was so that I can be able to collect these terms together. I can be able to collect it. That's why I had to bring in that into the equation. All right, so moving forward, if I have that, the next thing I'm going to do, I'm going to collect So I'm going to collect like terms, and if I collect like terms, I'm just print this, take this off. So this is the same thing as saying that I have 3 to the power of 3 2x plus 9 is equal to 3 to the power of x. The power of this is 28. 3 to the power of x, because 27 plus 1 is 28, and then I have my 3 to the power of x, 3 to the power of x. I have my multiplication sign, I have my multiplication sign. I have my 27 plus 1, which is 28. I have my 28. I have my multiplication sign, I have my multiplication sign. I have my 3 to the power of x, I have my 3 to the power of x. So basically, I have not really changed anything. Okay, so this is the same thing as saying I have 3 2x plus 9 is equal to 3 to the power of x. This is going to be 28. If I do that, this is the same thing as saying I can say 27 plus 1, just factorizing this into 3 raised to the power of x. Because this multiplied by this is going to give you this, and then this again multiplied by 1 is going to give you this. Alright, so just so that you'll be clear and not to get confused. So this is the same thing as saying 3 to the power of 3 2x plus 9 is equal to 28 multiplied by 3 to the power of x. You can call this equation 3. From equation 3, I can say let y is equal to 3 to the power of x. That simply means anywhere I see 3 to the power of x, I substitute y. So from equation 3, we have that I can rewrite equation 3 as 3 to the power of 1 multiplied by 3 to the power of x multiplied by 2 plus 9 is equal to 28 multiplied by 3 raised to the power of x. We've not changed anything here. 3 to the power of 2x is the same thing as saying 3 to the power of x multiplied by 2. This is the same thing as saying 3 multiplied by 2 times x. Same thing saying 3 multiplied by x times 2 is still the same thing, but I'm just changing it because I want, since I've said let y is equal to this, I want this to stand alone so that I can replace it with y. That's why I just did that rearrangement. It's for you so you can understand, but for me, I don't need to do this rearrangement. Okay, I just know that I'm going to have y square. I'm doing this because I'm teaching you so that you understand how I'm moving each step. Okay, so proceeding, this is going to be 3. Remember, we say let y equal to 3x, 3 raised to the power of x. So anyway, we say 3 raised to the power of x, substitute y. So I'm going to substitute for the whole of this. I'm going to substitute y. Multiply by 2, so that's going to be y square plus 9 is equal to 28y, which is same thing as saying 3y square plus 9 is equal to 28y. This is leading us somewhere. This is now 3y square minus 28y plus 9 is equal to 0. And I can call this equation 4. Equation 4 is now a quadratic equation. Quadratic equation having the highest power as 2. That's a quadratic equation and it must be equal to 0. Remember your quadratic equation? So it must be equal to, the equation must be equal to 0, and then the highest power of the equation is 2. So this is a typical quadratic equation. So for this equation, we're going to use the quadratic formula. And the quadratic formula, we call our quadratic formula quadratic formula states that you have minus b plus or minus square root of b squared minus 4ac divided by 2a is the quadratic formula. So from equation 4, we're going to call our parameters out from equation 4. From equation 4, we have that our a is equal to 3, our b is equal to minus 28, and our c is equal to 9. So we'll just substitute that into the quadratic formula and then we keep solving. So this is going to be minus, what's our b? 28, so that's minus and then minus 28 plus or minus square root of what's our b? Again, our b is minus 28 squared minus what's 4 is a constant. What's our a? Is 3. What's our c? Our c is 9. And then divided by what's our 2 is a constant, and what's our a? Our a is 3. Negative multiplied by negative, that's going to give me 28 plus or minus. And then 28 squared, that's 28. Multiplied by 28 is going to give me, this is going to be the square root of, I'll take that again, root of 28, that's 784 plus negative 28 multiplied by negative 28. Negative is positive. 28 multiplied by 28 is 784. Then we have 4 times 3, that's going to be 12, and then 12 multiplied by 9 is going to give me 108. Or divided by 2 multiplied by 3 is 6. This is something as saying we have 28 plus or minus, now 784 minus 100, and that's 108. 784 minus 108 is going to give me 676, all divided by 6. And this is going to give me 28 plus or minus the square root of 676 is 26. So now I'm taking the square root of 676, that's going to give me 26, all divided by 6. So here I have two equations. So the first instance is that I have two cases. Let's say case 1, I have 28. Remember, this is plus or minus. So first case is 28 minus 26 all over 6, which is equal to, that's going to give me 2 divided by 6, which is going to give me 1 over 3. And then the second case is 2 is that 28 plus 26. Remember, this is plus or minus, so that's 28 plus 26 over 6, and 28 plus 26 is going to give me, that's going to give me 54 divided by 6, and 54 divided by 6 is going to give me that's going to give me 9. Therefore, we have two values, which is 1 over 3 and 9. Yeah, all what we've been solving right here is just value of y. Okay, we've been looking for the value of y, all from equation 4. From equation 4, all down here, what we've been looking for is the value of y. Y is equal to this. Y is equal to this. Y is equal to this. Just been looking for the value of y. So therefore, y equal to this. But recall that y is equal to 3 raised to the power of x. If we have that y is equal to 1 over 3 and y is equal to also 9, this gives us that wherever we see y, we'll substitute 1 over 3. So the first case, we have case 2, case 1 is 1 over 3 is equal to 3 to the power of x. And this simply means 3 to the power of negative 1 equal to 3 to the power of x. Here the bases will cancel out because they are the same, so negative 1 is equal to x. Therefore, x is equal to negative 1. In the second case, which is the case 2, remember when y is equal to 9, case 2 where we say that y is equal to 3 to the power of x, and y is equal to 9, so that will be equal to 3 to the power of x. 9 is the same thing as saying 3 to the power of 2 equal to 3 to the power of x. So the bases will cancel out because they are the same. So therefore, x is equal to 2. So for this question we're solving, therefore our x, negative 1 and 2. This becomes the final answer to our question. So this brings us to solving this question, that we have 3 to the power of 2x plus 1 plus 3 to the power of 2 equal to 3 to the power of x plus 3 plus 3x. So in this question, our x is minus 1 and our x is also equal to, or our x equal to 2. So the beauty of mathematics is that whenever you get an answer, you can always test to be sure that your answer is correct. So let's test this, see if we are right. So remember, our x has two values, minus 1 and 2. Let's try for when x equals to 2. That means let's substitute 2 into this equation. Wherever we see x, we should substitute 2. So this is going to give me 3. Now let's see if it's our left-hand side. What we're going to get here when we substitute 2 will be the same thing we'll get on this right-hand side. So from the left-hand side, 3 raised to the power of 2. And where we see x, we put what? 2 plus 1 plus 3 to the power of 2. And that will give me what? 3. 2 multiplied by 2 is 4. 4 plus 1 is 5 plus 3 to the power of 2. Now let's see if it's the same thing we'll get here. This is 3 to the power of, where we'll see x will put 2 plus 3 plus 3, where we'll see x will put 2. So this is 3 to the power of 5 plus 3 to the power of 2. So you see that whatever we got from this left hand side is what we got is the same thing we are having on this right hand side. Now let's test for when x is equal to -1. Recalling this equation, when x is equal to -1, wherever we see x will put -1. So there's 3 to the power of 2 -1 plus 1 plus 3 to the power of 2. This is going to give me 2 multiplied by -1 is 3 minus 2 plus 1 plus 3 to the power of 2. And that's going to give me 3. -2 plus 1 is going to give me -1 plus 3 to the power of 2. Let's see if it's the same thing we'll get on this right hand side. So on the right hand side, remember this is what we have on the right hand side. We'll have on the right hand side. So let's do that. So wherever I see x, we put -1. So that's 3 to the power of -1 plus 3 plus 3 into -1. So this is going to give me 3 into -1 plus 3. That's going to give me 2. Because -1 plus 3 equal to -1 plus 2. -1 plus 3 is equal to 2. This is going to give me negative. This is going to give me 2 plus 3 into -1. Alright, let's see if it's the same thing. Oh, see, same thing we got here. I have 3 -2 plus 3 -1. So you see our answer is very, very correct when we test the value of x equal to -1 and the value of x is equal to 2. We're going to get the same thing on the left hand side and the same thing on the right hand side. So this is how you solve quadratic equations. You need to master the laws of indices. Sorry, this is how you solve indicial equations. You need to master the laws of indices. And you can see some indicial equations could lead you to solving quadratic equations. So you need to be grounded in algebra, because some questions will not just only allow you to work within the environment of indices. You need to work out of indices into a quadratic equation. Sometimes it might work into a simultaneous equation. So you need to be well grounded in algebra to be able to solve questions like this. So if you have any question, feel free to ask in the comment section. Like this video, please subscribe to this channel and drop your comments. If you have any question on indices, drop it in the comment section and I'm going to make a video solving that equation for you. See you in our next video. Bye for now.